so we are modeling Earth's revolution around the sun and seasons and the effect of sunlight on the earth. So the lamp in the middle is the sun, and in class we gave each student a card and asked them to organize the cards in the order that the months progress throughout the year. So we start with January, February, March, April, May, June, July, August, September, October, November, December. So we've got our entire year around the sun. Okay, all right, the next piece is we know that in the course of a single year, we have 4 seasons. They are winter, spring, summer, fall. So we've placed a season card behind each group of months that season belongs to. So for example, winter belongs to December, January, and February. Those are our 3 winter months. Spring then is March, April, May. Summer is June, July, August, and then fall is September, October, November. So every 3 months we have a new season. So the last part of our model is there are 4 major events that happen each year, each at a different part of Earth's revolution around the sun. So I'm closest to here, so we're just going to start here. So each winter we have a winter solstice, and this is when the night is, or the day is the shortest day of the year, and the night is the longest night of the year. So winter solstice, and you'll notice that opposite, can you grab that orange part, Mr. Cook?
Yeah.
Opposite of the winter solstice is the summer solstice, and so that is the longest day and the shortest night. So that's dead in the middle of winter, longest day, shortest night. And then opposite those, you have the other extreme, which is the days and nights are the exact same length. And those are called equinoxes. And equinox literally means equal night. Nox is Latin for night. So you have a vernal or spring equinox, and then you have a fall equinox. So each of these events is evenly spaced every quarter in Earth's revolution around the sun. So one of these events happens each season.
Go.
Okay, so now we're going to model seasons. We're going to see how Earth's revolution around the sun combined with its tilt on its axis are the reason we have 4 distinct seasons on planet Earth. So you'll notice I have my axis pointed to the North Star. The key to this is to keep the axis pointed at the North Star. The North Star is a pole star. Earth's axis is always pointed at the North Star. So here we are in Texas, and you can see that Texas, way up here, is not getting very much direct sunlight. There's much more direct sunlight down here in the southern hemisphere. So that means in Texas, it's winter, whereas in the southern hemisphere, it's summer. And that matches with what our cards say. Our cards tell us we are here in winter. So we're getting the indirect sunlight in the northern hemisphere. But now, as we move through the seasons, we'll come around here. Let me have Texas face the sun so you can see. All right, so now we're in spring, and you can see that the light is much more evenly distributed. It's hitting the equator, it's hitting the southern hemispheres at about the same strength. Neither one is that much stronger or weaker than the other one. And that's what we know about spring. We're transitioning to the longer days and warmer months of summer. So as we progress through the seasons, keeping the axis pointed at the North Pole, at the North Star, you can see that the northern hemisphere is getting much more direct sunlight than the southern hemisphere. And that correlates to our summer months. Keep in mind though, in the southern hemisphere where they're getting the indirect sunlight, that's summertime for them. So that means their June, July, August, that's, even though it's their summertime, that's their winter. It's cold. It's colder down there. It's exactly opposite for them as it is for us. So yes, at Christmas time, it's the middle of their summer season. Okay, so as we continue on through the year, with our axis still pointed at the North Pole, you can see we're back to a point where the sunlight is hitting at about the same angle in the northern and southern hemisphere. And so now we have equal day and night, and we're prepared to transition back toward winter, where we'll have the shorter days and longer nights.